Assalamualaikum warahmatullahi wabarakatuh. Welcome to our case study on wireless charger for electronic devices.
Okay, as you know, our project is wireless charging. So my part here is to explain a little bit about wireless charging. So this study explored wireless charging as a modern solution to the limitation of traditional wired charging, focusing on efficiency, convenience, and charging speed. It investigated the electromagnetic principle behind wireless chargers, compared their performance to wired alternative, and evaluate their potential impact on the future technology. I know you may ask, what is electromagnetism? So I'm here to explain what is electromagnetism. Electromagnetism can be divided into three aspects. The first aspect is overview of electromagnetism. The second aspect we can see in key discovery and principle. And the third aspect is application and significance. So the first aspect, overview of electromagnetism. Electromagnetism examines the relationship between electric charge and magnetic field with Maxwell equation and the Lorentz force law. So in the second aspect, key discoveries and principles. Faraday, Oersted, and Maxwell unified electricity and magnetism, showing how changing magnetic field induce electric currents and vice versa. And the last aspect, application and significance, we can look at the understanding electromagnetic fields enable the development of systems like wireless charging, where electric and magnetic field are harnessed for efficient and energy transfer.
Hi, there are three electromagnetic laws that have been applied to the case study. The first one is Faraday's law. Faraday's law states that a changing magnetic field induces an electromotive force, EMF, in a conductor, and the magnitude of the induced EMF is proportional to the rate of change of the magnetic flux. This law forms the basis of electromagnetic induction. The second one is Lenz's law. Lenz's law states the direction of the induced current in a closed loop is such that it opposes the change in magnetic flux at passing. This law ensures the conservation of energy in electromagnetic system. And the last one is Ampere's law. Ampere's law relates the magnetic field around a current carrying conductor to the electric current passing through it, stating that the line integral of the magnetic field around a closed loop is proportional to the current enclosed by the loop. This law is fundamental to the understanding between the interaction of electricity and magnetism.
A wireless charger is a device that allows electronic devices like smartphone, smartwatch, and earbud to charge without the need of physical cable. It operates through a technology called inductive charging, where an electromagnetic field generated by a coil in the charger transfers energy to a receiving coil in the device. This energy is converted into electrical power to charge the battery. Wireless chargers offer several conveniences, such as eliminating cable clutter, reducing wear and tear on charging port, and providing a seamless charging experience by simply placing the device on the charging pad. The left image shows our complete wireless charging circuit. It uses a ratio of 1:3 step-up transformer to increase the alternating voltage, followed by a full-wave rectifier to produce DC voltage with some voltage ripple. To smoothen the voltage, an RC filter is applied, and the LM7805 voltage regulator ensures a stable DC output, as shown in the upper right image. The schematic diagram of our circuit is illustrated at the bottom right figure.
For such a long time, many people use traditional method, which is wired charger, to charge their electronic device, which is not reliable. But since 2012, wireless charger have been a new technologies that have been used to charge their phone, which is easier. But how are we going to prove it?
Alif, I got an idea. This is a wireless charger receiver circuit. The coil with 15 turns captures electromagnetic energy and send it to the bridge rectifier, which converts it into DC voltage. capacitors move the DC voltage and the 7805 voltage regulator ensure a stable 5V output. This 5V can power small electronic device. First, we wind up the copper wire. First, we make 5 turns ratio. Second one, we make it into 15 turn ratio.
This setup uses a step-up transformer with a primary winding of 5 copper wire turns and a secondary winding of 15 turns. A full-wave rectifier with 4 diodes convert AC to pulsating DC. MRC filter using arc resistor and capacitor to smoothen the DC voltage. MLM 7805 regulator ensure a stable and clean 5V DC output.
Our graph, there's some distortion due to component. We got 5V as our maximum voltage. We use a red LED to make sure that the circuit is properly connected. This is the completed circuit of our wireless charger. And so we plug in the wireless charger into the phone, and there we go. That's all from us. Thank you. So we'll continue on to the analysis of result. So the study evaluates the performance of wireless charging, highlighting its strengths and challenges compared to traditional wired charging. Key findings focus on efficiency, heat generation, and potential areas for improvement. So the first analysis is the efficiency. Wireless charging efficiency depends heavily on the alignment of the transmitter and receiver coils. Misalignment leads to significant energy loss, making wireless charging less efficient than wired alternatives. And the second analysis is the heat generation. Heat buildup is a common issue during wireless charging, caused by energy losses from resistances and electromagnetic field dissipation. This can negatively affect device battery life and charging pad durability over time. And the final analysis that we got from this study is that there's many things to improve on this design. Improving in the coil design, material selection, and even the cooling mechanism are essential to enhance energy transfer, efficiency, reduce heat generation, and close the performance gap between wireless and wired charging technologies. And finally, we're at the conclusion of our study case. Wireless charging technology effectively utilizes electromagnetic principles, particularly Faraday's, Ampere's, and Lenz's law, to provide a seamless and efficient charging experience. Despite its convenience, challenges like efficiency loss due to coil misalignment and heat generation need to be addressed for improved performance. Continued advancements in coil design, energy management, and cooling mechanisms are essential to enhance wireless charging's efficiency, stability, and longevity. With ongoing innovation, wireless charging has the potential to become a more reliable and widely adopted solution, bridging the gap with traditional wired charging. And so, that's all for our study case on wireless charger. Thank you for listening and have a nice day.